Hola students, this is Ms. Overly with lesson 3.3, slope. By the end of this lesson, you will be able to find and use slope to identify if lines are parallel or perpendicular, or neither. So quick review of slope, write down what you need. You could not write what you don't need. Slope is rise over run. We model that with change in y over change in x. So, quick review to find slope. Remember, if we are looking at 2 points, or if we're looking at a line, we identify 2 points on the line, write down their ordered pairs, and identify x1, y1, x2, y2. And then we just do the change in y over the change in x. Most common mistake, of course, is mixing up rise over run, so be careful with that. Minus a negative, of course, turns into a positive, so our final answer is 5 over 4. Also, I know you know this, but a quick review, we read slope from left to right. So when it goes up from left to right, that's positive. When it goes down from left to right, that's negative. Straight horizontal lines are zero slope, and when we can't scale the wall, we call that undefined. 2 postulates from lesson 3.3. The first one is the slopes of parallel lines postulate, which just says 2 non-vertical lines have the same slope if and only if they are parallel. All vertical lines are parallel. So same slope is parallel. And the slopes of perpendicular lines says 2 non-vertical lines that are perpendicular if and only if the product of their slopes is -1. Vertical and horizontal lines are perpendicular. The other word for this, of course, is opposite reciprocal. So if the slope of one line is 4 and the other is the opposite of and reciprocal of that initial slope, then they are perpendicular. So 2 ways to check it. Their product is -1 or their opposite reciprocals of each other. All right, so let's look at our, we're actually skipping example 2. So you could label example 3 as example 2 if you would like. Determine whether lines A, B, and C, D are parallel, perpendicular, or neither. So we're given the points for A, B, C, and D, and they ask us to graph each line to verify our answer once we do that. Well, obviously we need to find the slope of AB, the slope of CD. So I would suggest you pause the video now and review finding the slopes of those 2. See if you can do it. All right, if you're playing the video, that tells me that you are ready to check your slopes. Were you getting 3 for AB and -1/3 for CD? If you were, you're ready to move on. If not, go back and check your work. Now, we look at those to determine if there's a relationship. And I noticed that if one is 3 and the other is the opposite of 3, and it's the reciprocal of 3, that they must be perpendicular. So, to check that, we can multiply them. Their product is -1, which tells me it is perpendicular. So AB is perpendicular to CD, and we can check it by graphing them, and it is true, they truly are perpendicular. They form a right angle when they intersect. Last example is example 4, but remember we skipped example 2, so you could call this example 3. They ask us to graph the line that contains this point and is perpendicular with CD. So I would say let's first find the slope of our CD. So you know the process, practice it, see if you can also get 3/4. And if we want to graph something that's perpendicular to 3/4, we would find the opposite reciprocal of 3/4, which is -4 over 3. And then we could plot that point A, which you know how to find. -3, 0 is right here. And then from there, we would just do our new slope, which is to go to the right 4, down 3. So our new line is this line, our old line is that line, and they are truly perpendicular. All right, thanks folks.